Hi everyone, welcome back to our statistics class notes. We're on page 106 of our class notes and we're starting section 7.4. And here's where we're going to get to some of the meat of our calculations. We're going to learn in this section how to actually construct a confidence interval for a population proportion. So we're going to start with a warm-up question. This is from actually page 333 in your text. Is it possible that more than 25% of Americans believe they have seen a ghost? A poll conducted in 2013 surveyed a random sample of 2,003 adult Americans, and 18% claimed they had seen a ghost. Estimate the standard error and find an approximate 95% confidence interval for the percentage of all Americans, adults who believe they have seen a ghost. Is it plausible to conclude that 25% or more Americans believe they have seen a ghost? So I'm actually not going to go ahead and construct the 95% confidence interval yet because you don't know how to do that. But this is an interesting warm-up question to think about it. So what do we know? Assuming the central limit theorem applies, which remember that means you have to have a random and independent sample. You have to have a large enough sample where you get at least 10 people saying no to the question and at least 10 people saying yes to the question. So we certainly have that. And you also need to have a big population, which we also have here. At least 10 times bigger than our sample size. So that all applies. So the sampling distribution of p hat is normal. It's a normal distribution with a mean of the true population proportion p and a standard deviation of the standard error, which remember is the square root of p times 1 minus p divided by n. Now we don't know p, so what we do is we use p hat, which is 0.18. So p hat is our sample proportion. That's 18% here, so we have to write it as a proportion, 0.18, as an estimate for the population proportion p. We also need to estimate the standard error using p hat. So I'm going to write that as standard error sub EST, and I'll say the standard error estimate. That's equal to the square root of p hat times 1 minus p hat divided by n. So we're plugging p hat in for p. So when I do that calculation here, I end up with 0.0089 or about 0.01, rounding it to 2 decimals. So what does that mean? So if we have a good estimate for the true population proportion p, then p hat, which is 0.18, will be close to the center of the normal distribution. So assuming it's right there at the center, and our standard deviation is about 0.01. So if I go 0.01, one standard deviation to the right, that puts me at 0.19. Another standard deviation to the right at 2 standard deviations puts me at 0.20. And I notice that if I keep going, every one is 0.01 more. It takes me to the 7th standard deviation above the mean to get the 0.25 or 25%. So thus it's not plausible since 25% or 0.25 is approximately 7 standard errors, in other words 7 standard deviations above the estimated mean. So if we were able to construct a confidence interval, if I taught you about that, then this 25% would not be in that confidence interval. Okay, so we're going to learn how to construct a confidence interval for a population proportion. Turning our focus towards inferential methods of statistics. So remember, it's often easy to calculate statistics from a sample. I mean, we can do it. We have it. We can push a button on StatCrunch. We can use our calculator, whatever we need to do. We can get statistics. But it's difficult and sometimes impossible to calculate parameters from a population. So we need to create a confidence interval for estimating the population proportion p. Okay, so just a thought example here, example 137. According to pewresearch.org, an October 2016 article indicated that 685 of 1,201 adults randomly surveyed favor the legalization of marijuana. So what percent of the adults surveyed support the requirement to legalize marijuana? So that's p hat, right? Comes from our sample. And that's 685 over 1,201. So that's actually the proportion, which if I put that into decimal form, it's 0.5704. So the sample proportion is 0.5704. If I change that to a percentage, it's 57.04%. Is that value we just computed a sample statistic or a population parameter? Hopefully I said it a bunch, but it's a sample statistic for sure. It came from the random sample, the people that were surveyed. And do you know the percent of all Americans that support the requirement to legalize marijuana? That would be P. No, we certainly don't know it. There's no information here, and there's no way we could find that unless we asked every American adult that question. Do you think the percent of adults surveyed who support the requirement is exactly equal to the percent of all American adults who support the requirement? That is our sample proportion p hat exactly equal to the population proportion p? Well, p hat is never, and certainly not likely in this case either, to be equal to p. But we do expect it to be close. Remember, it's an unbiased estimator. Its job is to estimate p. So as long as we meet all the conditions of the central limit theorem, it's likely to be really close to p.